Good morning, students. Welcome to lesson number 7 on circle theorem. The last time we met, we looked at lesson number 6 and theorem 5. Then we saw that it's about cyclic quadrilateral. So we said in a cyclic quadrilateral, opposite angles are supplementary, meaning that they add up to 180 degrees. So we identified one and then I gave you an assignment. We'll start lesson 7 with solution to the assignment. Then we look at the sixth theorem. I hope you all did the assignment. Good. So let's begin with the question. Now the assignment was, in the diagram below, O is the center of the circle. Find I, X, I, Y. So this is our diagram. Now you can identify that this diagram is a cyclic quadrilateral. So why is it a cyclic quadrilateral? Because it is a four-sided figure inside a circle where all the vertices touches the circumference of the circle. So once we are able to identify that the diagram is a cyclic quadrilateral, we apply the theorem on it. So we are to find I, which is X. So it means that from the theorem, when we add angle at E, which is X, to angle at J, which is 62 degrees, it should be equal to 180 degrees. So using that, we can solve for X. To solve for Y also, when we add angle at H to angle at F, which is 73 at F and then Y at H, we'll equate it to 180 and then we'll be able to solve for Y. So let's do that. So looking at the question, so we write our question number I. Now let's go back. So angle FEH, angle FEH plus angle FGH should be equal to 180 degrees. So angle FEH plus angle FGH should be equal to 180 degrees. Okay, so substituting, we have this one is X plus this one is 62 degrees equal to 180 degrees. And this will give us our X equal to 180 degrees minus 62 degrees. And our X will be equal to, so when we subtract, we get 118 degrees. Good. 118 degrees. So this is the answer to the I. So let's look at the II. So the II also, angle EFG plus angle EHG should be equal to 180 degrees. So angle EFG plus angle EHG should be equal to 180 degrees. Okay, so angle EFG plus angle EHG should be equal to 180 degrees. So substituting, we have 73 degrees plus Y is equal to 180 degrees. So our Y is equal to 180 degrees minus 73 degrees. And our y will be equal to, so when we subtract, we are going to get what? 7, 0, and then what? 1 degrees. Good. So this is the answers to our assignment. So x is 118 degrees, y is 107 degrees. Good. Now let's move on to our main lesson and on Theorem 6. Good. So Theorem 6 is still on the cyclic quadrilateral, but I would like us to deduce the theorem ourselves. Good. So let's look at it. So I'm using the assignment to help us deduce it. So what we have here is a cyclic quadrilateral. Now, if I extend this line, let's see. Okay. If I extend this line, I'll get an exterior angle here. Now, this line here is a straight line, and from plane geometry 1, angles on a straight line add up to 180 degrees. So now, when we want to find the angle here, it means that when we add 107 to the angle here, it should be equal to what? 180 degrees. I hope you get it. Good. So 107 plus what will give us 180 degrees? You can bear with me that it is what? 73 degrees. Okay, so it's 73 degrees. I hope you get it. Good. Now, if I also extend this line, the line here, okay, if I extend this line to get another angle here, which is also an exterior angle. Now this line is a straight line, so angles on a straight line will add up to what? 180 degrees. So if this place is 62, plus what angle will it give us? 180 degrees. And you can also bear with me that it will be what? 118 degrees. Okay, good. Now if I also extend this one, I'll get an exterior angle here. Now, still angle on a straight line. Subtracting 118 from 180 will give us the angle here. And you can also bear with me that it is 62 degrees. Okay, then finally, when I extend this line, okay, I also get an exterior angle. Now, still angles on a straight line. So, the angle here plus this should give us 180 degrees. And you can bear with me that it is what? 107 degrees. Good. So, let's look at something here. Now, when we extended this chord, we had an exterior angle. When we extended this chord, we also had an exterior angle. When we extended this chord, we had an exterior angle. And finally, when we extended this chord, we also had an exterior angle. Now let's look at something here. What can you say about the value of the angle here and then the value of the angle here? Good. So you can bear with me that they are the same. This angle here is 73. The angle here is also 73. Good. Now let's look at this one. What can you say about the angle here and the angle here? Good. you realize that they are also the same. This angle here is 118, and this one is also what? 118. Good. And then finally, when we extended this chord, we had this angle which is 62. So this 62 degrees here is the same as what? The 62 degrees here. Okay, so now what it means is that in a cyclic quadrilateral, if we extend a chord, okay, if we extend a chord and it forms an angle between an existing chord, the angle between the extension of the chord and the existing chord is the same as the opposite interior angle. So this angle here, 73, is the angle between the extension of a chord and a chord. Okay, the extension of a chord and a chord. And the value of this angle is equal to or the same as the interior opposite angle. Interior opposite angle. So this side is the interior opposite angle to this exterior angle. Now this one also is an extension of a chord which is an exterior angle, and it is also equal to the interior opposite angle. The same way, this is an exterior angle formed by the extension of this chord and this chord. So this angle here is the same as the interior opposite angle. The same way, 107 is an exterior angle formed by the extension of this chord. So now the angle here, which is the exterior angle, should be the same as the interior opposite angle. I hope you get the concept. So anytime there is an extension to a chord, the angle formed between that extension and the chord is the same as the interior opposite angle. Okay, good. So this is just specific values that we used to understand the concept. So now let's put down the theorem in a general statement. Good. So this is theorem 6, and it's about the exterior angle of a cyclic quadrilateral and its opposite interior angle. Okay, good. So from what we looked at, so this angle here is the exterior angle of the cyclic quadrilateral, which is n. And per the theorem, this n is the same as the angle here, which is the interior opposite what angle. Okay, so it means that n, which is the exterior angle, is equal to m, which is the interior opposite angle. Okay, so in a cyclic quadrilateral, the exterior angle is equal to the interior opposite angle. In a cyclic quadrilateral, the exterior angle is equal to interior opposite angle. Good. So students, this is about theorem 6. This is about theorem 6. Make sure you go over if you don't get the concept. Okay, and you get it. It's not difficult. Good. So we'll end our lesson here, and then I'll give you an assignment. Make sure you do the assignment. The next time that we'll meet, we'll start the lesson with the solution to the assignment, and we'll move on to theorem 7. So let's look at the assignment. So this is a beautiful question. Okay. So till we meet again, stay safe, revise, read ahead. Bye-bye.